So what I said,
This,
like once you import any library, let's like this one is a package. Inside this package, there is a model, a linear model, and from linear model, I am importing linear regression.
okay.
Okay, and here you imported. Once you import any library, what you need to do? You need to initiate first. There are three steps. See, look at first. You need to import the library. Next, you need to initiate it, and now once you initiate it, you need to fit the model. First, fit the model. What is the meaning of fitting? Fitting means you need to pass the data. See, you need to pass the training and test data in every model. Here, let's say like I imported linear regression. Now I'm going to import logistic regression. I'm going to import, decision tree, random forest, whatever, right? Import is okay. Same thing, only this one will change. Now you imported another model, you need to initiate it. How to initiate? Create a variable and then copy this and then bracket, open and close. Now you initiated it, and then the next job is to fit the model. So there are three.
This
Only
LM,
yes,
this
this
LM is linear
yeah,
model, right?
yes, this variable hold
Mm.
this entire thing, and then lm dot fit, and fitting means what? Passing the data,
To put it inside.
and the data is this one. X train. You what you need to
And
do?
Y,
You need to pass X train and Y train, right?
Y train. Okay,
So
okay.
I
This is
pass
very
here.
important.
Yes, I pass X train and Y train. Correct? I pass X train and Y train. And now when I pass, and here, if you look at why I created this REF, now again REF I need to, REF I need to initiate. I again created another variable REF, and I am initiating it here, right? Here I initiated without passing any value, correct? I'm not passing any value here, but here I am passing this LM, and then 10. 10 is a value, something like it will see there are 10 attributes, right?
Yes.
There are 10
Nice.
attributes. I am telling this, Python, I mean, this model, sklearn, to recursively do the feature engineering.
Okay.
I'm passing this LM I created here, and this 10 attribute, and telling them to choose the best attribute. I mean, it will do the, see, it will maybe like it will give, um, wait, maybe like it will give a little more weightage to this, little more weightage to the little less weightage, little, So what it will do automatically, this line will, what it will do from 10 attribute. See, this is kind of things, right? In real life as well. Like let's say, like, there are 10 people in a class. Maybe like there will be little, or else like in a project or in a company, right? Somebody will have higher weightage, somebody will have little less, somebody will have little less, something like that, right? Correct?
Yes, correct.
In if you look at the politics as well, prime minister will have high weighted, then presidents will have more than prime minister. So let's say like presidents have higher weightage than prime minister, and then the other ministers in the parliament, right? And then the government officers, something like that, right? So there are 10 attributes. So what it will do, machine will give automatically weightage to all the 10 attributes. Correct? Maybe it will give, because temperature is playing an important role, very important. Maybe it will give temperature higher weightage compared to season. Maybe it will give wind speed less weightage compared to weather, right? So it automatically, machine automate, because you have imported recursive, right? Feature selection. So see, we have already done manual feature selection, right?
Yes.
Manual feature selection, look at the example, a temperature, correct? Wind speed,
Yes.
wind speed, humidity, season, something like that. Feature selection we have done manually. But there are a lot of features, correct? So if we have some automated mechanism available, why should I go and do? Let machine do it, right?
Yes, just call it. Just call the function.
Yes, then that's why we imported sklearn feature selection library here, and I am passing here this one lm. This lm I am passing it here, and I am passing 10 attribute, and I am telling machine to do the feature selection.
Okay, good.
And machine will automatically give little and less weightage to the all the 10 attributes. Agree?
Okay.
So here I am fitting the data, and look at this data, and this one is not important. This one is not important. Okay. All right. Now,
Can we remove this or let's leave it?
no, let's keep it. I will. I mean, we will cover it later. This is not important thing to explain here. I am going to, and this one is also not important at the moment. I will explain it in the next model. Because see, this one will take again an hour to explain this. So this one I am ignoring it. Now you look at this. This data is created. I'm coming it here. Now here I'm dropping Monday because we have checked that Monday and Sunday, right? These 2 days in the data. Remember in the at the last, right? Monday and Sunday was actually similar, right?
Yes.
Look at this. Monday and Sunday, both are almost close, right? So we can either we can keep it or else we can ignore it. So here I am actually ignoring Monday. Let's take it only, Sunday. So Monday, I'm ignoring it here. And
because Sunday is the highest, so let's pick Sunday.
Yes. And here, this one is also not important. I will explain it later. I will take a little more time. This was X and this was Y, right? And this is a line, remember. And this one is some data point, right? This one is some data point. This one is some data point. This one is some data point. These are the data points. 730 records somewhere. Right? Remember the line equation that I was talking about. Y equal to mx plus c, right? This was the equation. So m is what? M is actually this. This is the data point, right? This one is a data point. M is actually, this one is what? Change in X, change in Y, right? This one is change in X, this one is changing X, and this one is changing Y, correct?
Okay.
So M is nothing but
which one is changing X? The one below?
Yeah, this one is X-axis, right? The change in X-axis. This one is X, change in X.
Yes.
And this one is change. This one is change in Y.
Y. Okay.
So change in X and change in Y is nothing but M. This line equation I was talking about, right? The change in x
Yes.
divided by change in y. The ratio is
Right.
nothing but m.
Okay.
Agree?
Mm-hmm.
Is it okay? Line equation you might have checked.
Yes, yes.
So this is the ratio. This m is nothing but coefficient, and coefficient is what? The change in x and change in y.
Mm.
Right? Let's say
Mm. Mm-hmm.
age age is of imply. Let me keep my pen. Give me a second. Let's say you are predicting based on you are predicting salary. You are predicting salary, and you have this one is y, right? Salary is y, and this one is x, right? This only one attribute. Let's say 25 age of 25, salary is let's say like 10K, right? And this 30, let's say 20K. This is the data, this data, right? So what is the
Mm-hmm.
change? If you are changing 1 year age, then what is the change in salary? So this one is x, so age is x, right? So what is the change, and what is the change in y? Correct?
Mm-hmm.
So if the age is changing 5 years, the salary is getting double, right?
Mm-hmm.
So here
Yes.
the change, this is the change. Let's say like this is 5 year change in x-axis,
Mm-hmm.
and salary is just double, 20, right?
10. Yes.
So this is the ratio. M is nothing but this change in x and change in y. And what is C?
Right.
What is C? See, here only one attribute age, right? But in our
Mm-hmm.
case, we have equation will be m1 x1 plus m2 x2 plus m3 x3, right? Because this one is what? Temperature, this one is humidity, this one is, see, if you have 10 attribute, then we need to keep m1 x1 m2 x2 m3 and till 10, correct?
Mm-hmm.
And what is C? C is something constant. See, C is constant. What does it mean? It means, see, we are predicting based on 10 attribute, correct?
Yes.
But will it possible? I mean, can we give 100% guarantee that only 10 attribute is responsible for bike riding?
No.
There might be something else,
Yes.
right? There might be something else. Let's
Mm-hmm.
take example football player, right? Ronaldo, correct? Have you heard his
Mm-hmm.
name?
Yes.
Maybe like how much goal Ronaldo is going to make tomorrow in the match. This is that you are going to predict. The people are doing the
Yeah.
gambling, right? On the match,
Mm-hmm.
correct?
Yes.
And they are using this machine learning.
Mm-hmm.
Okay, so let's say the situation is Ronaldo is going to, how much goal Ronaldo is going to make, yeah, tomorrow in the match. This is the prediction that you are going to do. And what you did like you have considered all the factors. The first attribute will be, let's say, like the weather condition. The second attribute, let's say, like his physical condition, the home ground, right?
Mm-hmm.
How much goal he has done in the past on that ground.
Mm-hmm.
Maybe you consider all. You gathered all the data and you build the model.
Mm.
Still can you can
Okay.
you still can you guarantee? No,
So even as that, I cannot guarantee.
we can't guarantee, right? Because there might be a situation, there were some dispute at his home uh, with her wife, and they might fight it, and he was not slept much that night, and next day he was in the ground, and maybe like he might be tired. He will not, this might be the situation, correct?
Yeah, that will affect him. to
So
play well.
this C is something which is
Constant.
constant.